So now let us have a look at a problem that can express the formula in a more practical way. Let x be a continuous random variable that is normally distributed with a mean of 25 and a standard deviation of 4. Find the area between x equals 25 and x equals 32. Now let us have a look at this problem. So we need to work out the value of z under these conditions. So say one x running between two values, 25 and 30. Say between 25 and say 30. So you're looking at the probability, but what is probability when you look at the normal distribution curve? Probability is area under the curve, right? So we know that z is equal to x minus mu over standard deviation. So when x is 25, when x equals 25 and standard deviation is 4, sigma equals 4, and the mean now when x equals 32, what do you get? Now let us have a look at the calculation. Z equals 32 minus 25 over sigma, which is 4. And this is nothing but 7 over 4, which is equal to 1.75. Now let us have a look at x being 25. So we're going to erase this now. We're going to look at x being 25. When x is 25, in the formula where you have 32, that's going to be equal to 25. And now 25 from 25 is 0. And 0 over 4 is equal to 0. So what you'll have the standard normal value. Z is going to be 0 and z is going to be 1.75. So we're looking at a space when z is 0. So we're looking at this space here. That space when z is 0. Now you could use the table. You could use the table to express this area space, which is interpreted as probability. Having the z values, we can now find the probability, because the probability is going to be probability of the random variable x, which is 25, is less than an x value less than 32. This is going to be equal to the probability of the z's, which is going to be, in one case 0, 0 less than z, and z less than 1.75. probability of the standard z running between 0 to 1.75 must be found from the table. Now on the table, which is represented like this, here are the z value and here are decimal values like 0.01, 0.02, 0.03 and so on, so 0.04, 0.05, point. Now for z equals 1.75, you will have z equals 0, 1, 1.5, 1.7. So for 1.75, you would match your z at 1.7 here, go right across. And the number that comes under 0.05 and 1.75, this number here is going to be 0.4599, and this is the probability. Okay, so once you're finding the z value, the probability of the z value, you must use your tables. I am going to upload a table from which you can do some examples. Alright.